Alright, this is a quick video on polynomial long division. So if we have a problem like this where it says x squared plus 3x plus 2 divided by x plus 1, first thing we might normally do here is factor the top. Factor the top. X plus 2 times x plus 1 and x plus 1. And then we notice that we got a factor, x plus 1 is a factor of the top and the bottom. And we'd be able to just cancel out the x plus 1s, and that would leave us with x plus 2. However, what happened if I had x squared plus 3x plus, let's say, or better yet, let's go minus 40 divided by x plus 1. Okay, so when we go to factor that, we get x and 5 and 8. And that'd be plus and minus. And over here we have x plus 1, and nothing cancels, okay? So you could say that this is written in simplest form, but another thing we can do with this is we can actually divide x plus 1 into the top polynomial and see what remainders we have, and which is something we do like, it's kind of like writing as a mixed number. Like if I have 15 over 5, I would rewrite that as 3, but if I have 16 over 5, I would rewrite that as 3 1/5, wouldn't I? Because 5 will go into 16 3 times with 1 left over. Okay, so we're going to do the same thing here. I'm going to take x plus 1, and I'm going to divide it into x squared plus 3x minus 40. Okay, so the first step, like normal long division, is you ask yourself, how many times will x plus 1 go into just a small part of it? So like, for example, if I was dividing 3, oops, that looks like a square root. If I was dividing, like, say, 3 into 478, you know, or actually let's do 32 into 478. So since there's since there's a 10s and a 1s here, we would start over here above the 7, and we'd say what times 32 equals 47, and we'd say, oh, it looks like just 1, and then we'd multiply 1 times 32 and write it down here, and then we would subtract what we just put down there. So 7 minus 2 is 5, and 4 minus 3 is 1. We have 15 left over. Then we bring down the 8, and we say how many times will 32 go into 58? 158. And that will go in there about 5, probably 4 times. So we put a 4 up here. 2 times 4 is 8, and 3 times 4 is 12. And once again, we subtract, and we get 30. So then our answer would be 14 and 30 seconds. Okay? So we're going to follow that same pattern over here. A little bit different because we're dealing with binomials and polynomials, but same idea. So because there's 2 terms here, I'm going to go over to the second term here, and I'm not going to look at both terms at the same time. I'm just going to say what times x equals x squared, and the answer of course is x, so I put an x there. Then I multiply, just like I did here, just like I multiplied 1 times 32. I'm going to go x times x, which is x squared, and x times 1, which is x. Okay? So then I'm going to go ahead and subtract what I just did, just like I did over here. And x squared minus x squared, of course, is 0. That's what we're shooting for. And 3x minus x would be 2x. Okay? And then we bring the minus 40 down, and we do it again. So this time my answer is going to be over the 40, and I'm going to again ask myself, what times x equals 2x? And of course the answer is positive 2, so I'll put a plus 2 there. And then I multiply. 2 times x is 2x. 2 times 1 is 2. Then I'm going to subtract that. 2x times minus 2x is 0. And negative 40 minus 2 would be negative 42. And of course x plus 1 won't divide into negative 42. So then my final answer is going to be x plus 2 plus a negative 42 over, and remember I took the 32 and put it on the bottom here, so I'm going to put the x plus 1 on the bottom there. So this is kind of like a mixed number polynomial. So there's kind of like the whole number, the x plus 2, and there's the fraction part. Okay, so this is called polynomial long division. Let's do one more. And actually, I want to show you what would happen if we did this one. Okay, so let's just do this one using long division. X plus 1 will go into x squared plus 3x plus 2. Let's say we weren't very good at factoring, we didn't notice that. So we do the same thing. We'd say what times x equals x, or I'm sorry, what times x equals x squared, and the answer is x. So x times x is x squared. X times 1 is x, positive x. Then I subtract, and I get 0 here, and 3x minus x is 2x. Bring my 2 down, that'd be plus 2. And I say what times x equals 2x, and the answer would be 2, of course. And 2 times x is 2x. 2 times 1 is positive 2. And then when I subtract, notice I get 0. So what does that mean? That means the answer to this division problem is x plus 2 plus 0 over x plus 1, or in other words, just x plus 2. So when I divide x plus 1 into x squared plus 3x plus 2, I get x plus 2, which is really what we discovered up here, isn't it? I divided x plus 1 into that polynomial, and x plus 2 is all that was left over. So it just confirms this idea that I can cancel, right? When I'm canceling, I'm really dividing x plus 1 into that polynomial. And there we see it actually happening. Okay, I'm going to upload this and post it real quick.